Hi there, and welcome to yet another stream from me. Uh, so I actually worked a bit more on the belt system, and I decided that I might as well just start this stream. Um, but yeah, this will be a somewhat slow morning stream where I work on dynamically adding some um, well, some more belt stuff. Anyway, I decided that I would want to, and yeah, by the way, I fixed the tick stuff, so the movement is more smooth, but yeah, I decided that I wanted to actually dynamically draw these belt segments, so I've added some data structure for that and some small 2D vectors here for manipulating our items. So right now I just add the belt piece with a standard direction here, and let's do let's see. Let's try doing something like Directx XM float start pause. And let's see if we can get our stuff to draw. Let's see, whenever I did the create the draw params here, C-span, model scale. Yeah, I didn't manipulate anything actually. It seems. Yeah, sure. So it should just map to an y offset of 0. Let's see, mesh data. Let's do build draw and then calculate a transform. Build transform here, but let's set the values for it. Build transform. Start parse.x. Let's do the same thing for the C. Oh. Let's try and see what happens if we do that. Right now, we don't do anything. And why is that? Is it because it gets rendered somewhere else or? No. And these standard values, transform data, scale 1, 1, 1. Should be fine, right? Do we even do this? Enter loop. Yeah, maybe I don't enter the loop yet. Uh, and let's see, build draw params. Okay. Let's step into this function then. Okay, let's see. Build draw, mesh index 0, material index, draw flags. Oh, of course. We do not have any draw flags. And therefore it doesn't get rendered. Okay, let's of course manipulate the scale a bit. Build transform. Let's see, Y, C, Y, and C. Okay, so we actually have our first conveyor belt part here. Yeah, I'm not sure this is actually useful, but we'll just keep on doing it. Make some float here. Current pos 0, 0. Is actually equal start pos here. Well, maybe we just want current pos. Let's see if we ever need the start position. Current pos. And then update current pos. X plus equals the let's see, const unsigned int type equals piece. Okay. Of course we Oh, there we go. And then plus equals segment dot belt pieces. No, not belt pieces. Types type dot x factor. There we go. Okay, so if we add another one, we should see belts. Oh, that's way too many. Belt pieces size. Why do we end up? Let's see. Piece. Let's just see how many times we do this. 0, 1, 0, 1, 0, 1, 0, 1. But that's not. Yeah, so it only happens 2 times. Hmm. Then they will be drawn on top of each other. Oh, there we go. So for some reason, if it's a, do I affect it? Why does it? Why does it add so much up? How many times do I do this? Segment index. Segment index. Oh, we have several segment indexes. Why is that? How is that possible? Huh? Am I misinterpreting something here? Might be. Do test setup. Belt pieces is the segment itself. Do test setup should only happen once. Okay. Eight belt segments? What? Belt pieces 2. Why does it repeat it so many times? Entry gap 0. Huh? How many times is this called? Oh, do I have some kind of repeating loop? I think I do somewhere. Let's see, do test setup. Yeah, we do it. I forgot that we actually do it for each build piece. Okay. Okay, that made sense. Okay. No reason to step into this part anymore. And then we can actually leave this. Okay, great stuff. Let's call it end position because it's actually our end position that we calculate. Okay. And then let's create an belt that actually should create an upturn. So this should be the one. And then let's create another piece that is the basic upwards going one. Oh, this is obviously not what I anticipated. So let me look into my types here. So the first ones are this one. We have two of those. Then we have 0, 1, 2, 3, 4. We have one that oh, it's because actually it's flipped. So if I, from my diagram, let me just swap this then because I misinterpreted the way the x-axis and c, or rather the c-axis is oriented here. I'm not gonna bother. I'm just editing some paint stuff here. This diagram is so messed up now. Okay. 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 So now what I meant to do was actually like this. And then these are actually also flipped. So one is actually in the other direction. So let's see, it should be 3 instead. Yeah. Okay. For some reason it doesn't know how to draw it. Uh, let's see. So we calculate our end position, which right now is our transform center, which is probably not great. So even though it recognizes the path that I've created from the types, it's not great. Let's see, so when we try to draw the, let's see, can I do a conditional breakpoint here? Conditions. How do I, where do I set the conditions? Did Visual Studio just crash on me? It did. I can't set conditions or what? No. Okay, great. Okay. Guess we don't do that. Okay, so So what I'm doing here is actually we're adding the 8th one, which means that we have 4 segments. Oh, it's because it's rendering it wrong, right? Yeah, because we have, oh, let's not spam that. Because if I kind of like move this, we have the first segment, which is this one. Then we have the next segment, which is this one. Then we have the combinatory one. Ah, maybe we want a half instead. Yeah, because one tile is actually too long. It can only be half a tile here. Yeah, a whole tile is uh, well, I think we all run into trouble with this solution as well. So my intuition says yeah, so yeah. Yeah, let's not do it like that, because this is just direction vectors. Okay, so let's draw them differently. So in order to find our center, let's do something like we have the tile center for each position. Which is right now our segment center as well. Model center. Mm. And let's see. So that's just basically grid slots. So maybe we don't want Yeah, maybe we don't want two types here. Let's do directions. Let's duplicate this. Tile offsets. So let me see. Let me open my paint diagram. So the first one should advance. Also, I need to swap these. Let's see. Yeah, so if we, so this should move us down on the z-axis, and this should actually the first one should not move us on the x-axis, but should only move us on the z-axis. It should change the direction, or rather the tile. Okay. Okay, so this is the direction in terms of tiles. Let's see, build a system, no problem here, but tile offsets here. Let's try using that instead. Yeah, there we go. So this is actually the way the belt meshes are supposed to be drawn. Okay. And let's see. Let's just do something really slow here. Something really slow and inefficient. F type above 3. Which type case 4 break. This is going to be so slow. Hello, how are you doing? Maybe we just want to let's see. change direction of quaternion from vector. How does coding work? I'm not sure what you mean by that. Um, uh, okay. We can do that later. Right now, we don't care about the model itself. Okay. So now we should start manipulating our stuff here. Okay. Maybe let's not set this. Anyway, let's see. So we at least draw the meshes. I'm not sure we need to store the end position here, but let's see. Also, in the builder system, let's see. Yeah, maybe it's because of the crash. Anyway. Let's see. Let's decrease the. So when we add the item, let's instead do let's do belt pieces.size here. Okay. Yeah, so it only moves. Oh, then it. Okay, it's bugged. Anyway, I gotta do a bathroom break. Be right back. I'm just gonna brew a bit more coffee. Uh, hopefully. Didn't I actually have sound on? I did. Okay. So, what we're gonna do here. Okay. Let's see. So this doesn't need to know about the actual position of the belt, but because it doesn't care, or should not care at least. Let's see. So let me just grab some stuff here. And let's see. So this doesn't care. It's still fine. it will calculate like a total entry gap. So 1, 2, 3, 4, 5, right? And potentially we should see a, or rather reduce this -1. Yeah. Maybe. Oh, let's see. No, never mind. For now, we'll leave it as is. Yeah, so whenever an item is placed on the belt, the exit gap will be the total length, which is fine. Okay, and then in our building data store, let's do xpos start, xpos start, and in our builder system, in our tester here, xpos start. Not, let's see. cpos start. There we go. Okay. And in here, when Visual Studio crashes, makes it clear the cache or what? I don't know. Apparently it opened everything up. So we have our belt pieces here. Right now it does work. Okay. Then we need to manipulate some variables here. Let's just start out by doing something like this. Because we want to redo it. Let's move it outside here, item scale. Okay. Okay. So let's rewrite this. Let's see. Item start pos X. Item start pos C. And let's do segment dot export start. cpos start. Great. So we have an item that we will be able to create. Let me just grab some coffee here. Yeah, so let's create our item. Let's see. So if we have an item, we will render it. Yeah. Let's do for yeah. So we won't do anything unless we have an item. And let's see. I added an item, but oh, I probably just didn't click it right. Let's see. Oh, it's because it's offset with a1 at the beginning. Okay, yeah, so okay. So in order to render this, let's do a float offset into lane X, or rather, okay, let's just call it this for now. And that should be a total value of its position on the kind of like transport belt, right? So it should be starting out by being the well, it won't know it yet, so we're starting off by do we okay, for each belt segment we want to actually do something different. So if we're like, let's try to draw this. So we're like having a curve of sorts, right? So it has the total length of the whole belt. So let's say, oh, that's fine. Let's say that we want to calculate something here and here. We know that this is created with chunks. Which will have the actual direction itself. Yeah, but we only know the position of, or rather the chunk from the actual yeah, so Maybe we do want the end position. But we do have that outside, so we can access that. Okay. Would we rather have the end position? So in order to calculate the item position on belt, first item equals the exit gap Okay. Second item equals exit gap plus first gap. Third item exit gap plus first and second gap, so forth. Let's see, relative. Maybe if we add all the directions together. So if we have the exit gap, if we decide that 1 unit of moved distance equals 0.1 segment or belt piece. So the exit gap So the amount of belt pieces minus the exit gap let's see, converting load to int C++ truncation. Okay. So we can actually round down. Okay. Yeah. Let's see. Let's just try doing that. Exe core print unsigned const unsigned int index equals the segment dot size minus the segment dot exit gap unsigned int current piece index. Yeah, let's try debugging that. Yeah, so we see that it actually current piece index here. Whoops. And whoops. Okay. Exit gap. Pieces. Okay. So we get our debug information here. Okay, it shouldn't go under 0. Anyway. Yeah, so we have 4 belt pieces. Okay, seems like we actually might be looking up the correct things, although maybe I want to add a okay, let's try that. And let's just simulate it like that. Okay, so we have yeah, maybe not. But let's keep that in mind. Maybe we want, when we floor this, to actually be something that we're mindful of. May need to add 0.5 to exit gap before subtraction. But we're having, oh well, I guess it overflows. So let's see, it overflows because there aren't supposed to be, what do you call it, 4 indices, because there are only what do you call it? Let's see, -1, perhaps. Yeah, so that's undefined. And what happens if we +1 or this? Yeah, so that seems to be clamping the index, at least from what I see. No, it doesn't. Okay. Hmm. Let's see the exit gap itself. It gets too big, right? Shouldn't be able to. So we end up in a state where what's that bit of error? I don't know where that stems from. It's perhaps the calculation between. Let's just. Oh, let's close all of this. Okay. So when we do in our system here, where do we lose position? Where does that small error enter the system? Well, maybe it's because of the well, the entry gap itself. Oh, it adds some garbage values there for some reason. Let's see. What size here? And then how come does it end up being that weird? I don't know why it ends up corrupting like that. I mean, let's see if we actually have any items. But I mean, it shouldn't be possible to. Why do I? Huh? What's affecting the entry gap? What's affecting the entry gap? Nothing affects it right here when we do the uh, segment exit gap equals build pieces segment dot build pieces, that size. Let's just do that. How does it end up corrupting? Is it just because I'm GUI? No? That's weird. That's weird. It's not related to ImGUI, right? Okay, so ImGUI does some weird interaction where it actually adds potential decimals or what? Ah, whoops. Huh. Now that's weird. Uh, so let's see, float, subtraction, sudden, imprecision. Okay. 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 So I shouldn't care, it seems. Anyway. I'll just output whatever, so I don't get stressed about it. Okay, let's get back to whatever I was doing here. So let's see. So the exit gap is 4. And right now our curve has 4 segments, so let's try that. So it has 4 segments, right? So 1, 2, 3, 4. That's actually correct. So when do we transition from one index to another? So let's say that this is the first belt piece. So that is actually index 0. I equals 0. Okay. Let's see, size equals 4. So when we're like, when we're here, the exit gap is 4, which means that our index will be 0. And then we need to be able to subtract 0.95 or something like that. Because we allow our exit gap to reduce by 0.5. Yeah, so this is not getting computed correctly because we immediately round down. So maybe the solution here was correct. So let's see our exit gap here. We keep on running down, running down. Okay, so actually we should probably add 1 to it instead. Okay. But do we overflow? Yeah, we do. So it works when, okay, when the exit gap is exactly yeah, so a couple of tick, one tick later, we have this value here. So whenever we do the subtraction, maybe we want to clamp then. Or maybe even just let's see. Okay. So that works. Yeah. And this should stop. Oh my god, this is cumbersome. Let's see, index equals std clamp. Index 0 and can I do it just like this? Let's see, unsigned int. And this expression here also will be cast. Okay, let's see. And then let's just remove this. And let's see. Yeah, that's not correct. That's not correct. Let's just process it all the way. Oh, I didn't. I'm too fast. Let's see. Okay, we drop it. Okay. 0 all the way. When do we transition? We transition when we're right at the boundary. No, we don't. Or we do. When we're right at the boundary. When we're right at the boundary. We could also do something like this -1 or something like that. Let's try that at least. Maybe it, oops, makes more sense. So let's compute the exit gap here. Okay, this is actually a more elegant solution, at least so it seems. Yeah. It will clamp it then to whatever value we have. Will it overflow? Let's see if we happen to test the wrong tick here. Yeah, it will. Let's see. Max. Unsigned int here. And let's do is it minimum? 0. Yeah. Let's see. Let's see. Okay, let's just cast the whole expression here. Unsigned int. Do we need to cast the whole expression or just this? Okay. Okay. Oh, of course. This is not the way to do it. Let's do and let's do unsigned int here. Okay. Maybe we do want to do the float subtraction instead. Okay, let's try that. Let's see, float minus this, and then this is what we do. Does it overflow still? Yeah, it does. Because it's negative. Nah. And let's see. Yeah, then the overflow ends up being too big. So this fixes the potential error here, and it fixes the but our boundary here is not correct, is it? Isn't it offset? Yeah, this is holding up way too long. So it's not correct. This should swap. Yeah, so that definitely doesn't work. Does this? No, it doesn't fix the other boundary issues we have. Yeah. This should result in index 1. Okay. Let's truncate the float again. So this should always be 1. It should always be 1. And then the exit gap could potentially be 1, which would be correct. And maybe I just need a okay, so I have this, and I'll truncate this plus a load epsilon, perhaps. Okay, let's see what that gives us. I clicked it twice, but shouldn't be a problem. Let's see. Maybe minus. Uh, uh, it doesn't work because it will be around 4. But if I subtract this 0.5 here, which is the increment or boundary decrement, we won't fail whenever the value is exactly equal to the amount of indices. And perhaps that's the most elegant solution. So the first check, or whatever, and let's see, the boundary is then exactly at the value there. Yeah. Yeah, this works, it seems. Okay, let's do that. Yeah. This is the solution we will use. Okay. So we calculate our potential index here. Which is the first belt piece whenever the exit gap is big. And maybe we just want to compute the values, accumulate the values. So maybe we do that. So we have the start position. And then we want to kind of like calculate the direction of the object. On our belt from our belt pieces here. We have these directions here. That we could use to modify the object. Right now, we're not actually moving it. Because we're not applying the so-called curve of the movement of the object. So we figured out a way to index these segments here. That means that we can look up the current direction. Let's see. And then for each of the segments, let's see, float X direction, float Z direction. Then for let's do segment. Let's see then. Segment dot belt pieces I type segment dot directions. Const. Let's do this. Okay. Let's add the xdir plus equals ref.xfactor setdir cfactor xdir divide equals float index plus 1. And let's do the same thing for this setdir. Item direction vector xdir setdir. Okay, let's debug that to our console. Yeah. It's not correct, but let's see, add index. So it's not exactly correct. Okay. So the direction vector is correct for the first object here. Also, the next one, but then we end up having problems when we try to turn. Maybe we want actually to do the tile offset instead. Yeah, it's not correct. Yeah, so we're like, then, yeah, this should be, yeah, probably we don't want, but we want to accumulate, right? Yeah, so this is not correct. Let's see, directions here. Yeah, so we're still correct at 1 and 0, and then we enter. Hey, Bob, how you doing? Yeah, I was AFK for like a while. Yeah, so this is very wrong. Maybe we don't want to accumulate. Maybe we just want to do it for a couple of vectors. Let's see. Let's do it. So this is not the way. It's obviously wrong. Um, uh, maybe the previous one. Uh, uh, and let's do directions. Yeah, this is obviously wrong. So let's try to figure out how to do it. Maybe we just want to normalize it. No. So right now it will be, so the direction vector should be, for the item here, it should be 1 on the x and 0 on the z, 1 on the x, 0 on the z. And here it should be half of this. Let's see, normalize vector calculator, normalize vector. Vector endpoint 1 1, vector length 1. Zero point blah blah blah. So that's, is that what we want to do? Yeah, so if it has to be unit vectors, I guess we have to do like this, because now right now we're not having unit vectors. Let's see. So let's do something like this, and then for every one of the okay. Let's try using that, and then let's see, item direction vector blah blah blah, and let's do like this again. So 1 1 1, and then of course we run into different rounding errors, so this is not correct as well. Okay, let's see. Huh. Yeah, let me rethink this. So let's see. We now know which segment we are at by using the exit gap calculation. Although this should obviously be minus 0.5, I think, or depending on yeah, we can use the segment. Let's see, minus the segment dot belt pieces 0 type, of course, and index into our segment tile offsets dot x factor, and let's do c factor times 0.5f. Is this actually a float? Yeah. Times 0.5f here. Yeah, so we start at our correct position now. Also, if we change the first belt to be something like this instead, we would end up creating, yeah, so it works. Okay. So we start our object here, and then we want to use the exit gap to kind of like offset, or rather update the position, right? So for the next two tiles, it should be fairly simple. Do we want to use the exit gap? Maybe we don't want the index itself right now. Do we want to accumulate the path position? Huh. Yeah, so we have the index, but maybe we were not going to use it right now. So the start position is correct for whatever belt piece we have. Okay. The exit gap. And whenever we add an item, Maybe we should clamp this. Maybe std max of 0. I don't know. Okay. So we have our exit gap here for our first item. As this decreases, we should, of course, move the object. Maybe we just want to add. Okay. Yeah, so let's do direction. For this belt here. Let's do a float item pos x just as a temporary item start position x here. X set here. Set, of course. Let's see. And we can actually do maybe we could do a previous index. Maybe we don't want that, but so whenever we do our stuff here, so the current index is supposed to be affecting the direction. Let's just do something fairly simple. Item pos x plus equals the direction x factor times 1, and then the c factor here. It moved around. Okay, we can calculate 2 positions, right? Okay. So if we do next X, no. The direction, now this is tricky. This is pretty tricky. We could also just store maybe. Do we want to store something different? So our build pieces. Maybe instead of storing a type, we want a relative offset. I mean, changing the way that we render, this is not difficult. uh, yeah. If we store our relative offsets on these belt pieces instead, will it help us? Mm, okay. So if we store the relative offset of each, or rather, yeah, offset of each belt part piece, and look that up, we would automatically know where the object would be, and we could actually interpolate between two positions, I guess, from the remainder of whatever exit gap we have. Okay, so maybe that's better. Simply just have relative positions that we store instead of directions. I don't know, maybe. Maybe that's better. And then we would get the so for index 0, that would give us a problem when we, so if this stores the offset, then at the beginning, this curve is problematic. So we also want to use the exit gap itself to actually move the object along whatever part of the path. So how do we define the actual path for rendering? For the visible object, we need to compute their position in space, because when they're not visible, it doesn't really matter. The absolute position doesn't matter as long as... So how do we transform from relative space into absolute space? So it would depend on... Yeah, maybe we want to store the relative positions of whatever... let's try that. Okay. Inside build pieces, let's create a version here that is different. Okay, let's see. Int x offset, int z offset. There we go. And then when we create our stuff here. Let's do 0, 0, and then let's create one on the x-axis here, and then one on the, oh, let me copy this and put it in a comment for backup. Or maybe up here. Okay, so 0, 0 is the relative offset of this one. Then we have 1, 0. That's this one, and then we do 2, 0, and then we do 2, 1 here. Okay. Right now, let's see. Okay, right now this won't break anything, and then let's not look up a type. Npos. We don't need this anymore, I think. And our segment itself will have a position start. Okay, let's comment this out. Let's comment this out so we can always revert. And then let's do a render here, and then this, and then segment dot xpos start plus segment well piece const piece. Okay, I need to change the name, of course, but offsets, offset, x offset, cpos start, c offset. Whoops. Okay, let's try that instead. Does it still render our okay, where's our problem? This. Let's remove that. Okay. Yeah, okay, so it actually, let's see. So in my builder system, yeah, okay, so this means that it's actually on the positive part of the whatever. That's fine. Okay, and then let's say unsigned int okay, so what we want to do is we want to compute some stuff. Of course, we do. So we have whatever belt segment we're actually on right now. That's our index. Let's see, get get decimals of float. Let's see. Interpolation equals 1 minus, let's see, float hole equals std floor segment exit gap, at least for now. Minus hole. Hello, how you doing? Okay, so we have our absolute positions now. So let's just do, oh yeah. Maybe we want the, oh. We kind of like need an previous. But we could kind of like deduce it from which way the belt is pointing, right? Because if this points, or the next piece is, yeah. But for a one-piece belt segment, Maybe we want something like a previous offset, like cached. Yeah, so if we maybe we want that. Because we store the position start. Maybe we just want two floats. Or maybe first piece type. Yeah, maybe we just want to store that. Okay. First piece type, which is true since it's just set like this. So segment first piece type, just to be explicit. Okay. And let's do tile segment first piece type, and let's do the same thing here. There we go. So yeah, and if we change the type here so that it was actually something that was pointing up or down, yeah, great stuff. Okay, so we can control that. Mm. Mm. Okay. Next, we want to calculate our item positions here. We could always just say that if we ever create something, so let's say that we want, if we have a one belt segment transport line for whatever reason, then the first index will be, of course, this, and it will never go beyond beyond 0. That's an error. But what would happen if we, for single pieces, added another piece which would hold the endpoint? Right now, belt pieces are just these offsets here. And we could add like a final belt piece that stores the final direction. Yeah. Okay, if we do that. Let's duplicate this and then simply subtract one here. So we don't draw the last one. Yeah, we don't draw it, but we do have the that would potentially be then it's supposed to point in uh, this direction here, right? Last one stores the end point of this belt. Follow barrier. And then we would always offset like this. Also, when we create the entry gap itself, we would have to do like belt pieces -1, and then in our updating of the belts here, gaps, let's see, -1. Right now, that's what we will do. Yeah. Okay, right now we will do it like that. So we actually are allowed to like do this no matter what. Int next index equals index +1 because we won't overflow. Okay. Let's do on int delta x minus next index and delta c. And let's do this as well. And let's try doing some item position x. Plus delta x times the interpolation. No. Let's just try adding this. It won't be correct, but let's see, plus. Hello, how are you doing? So we're actually ending up not entirely correct where we want to be. But at least we're moving. Let's do times interpolation here. This is so weird. Yeah, I'm doing a transformation from a relative space on the actual conveyor belt into absolute coordinates. Let's see. Actually, I think maybe this is wrong. Let's do something like let's do I just updated the simulation tick. It was not really a problem with the rendering. Once we hit 60 updates per second, everything smooths out. Yeah, it turned out it was as simple as that. Let's see, so this is actually relative, so maybe we just want maybe we don't want this stuff here. So let's see. Hello, how you doing? So actually maybe even if we just add our item position x equals item start position x plus this will move it, I think, in yeah. So we of course need to smooth it and of course offset it correctly. Uh, and add gaps and everything like that, but okay. We're kind of like getting there. Also, these values correspond to it being at the end of the kind of like curve. Luckily, we will only do this for the stuff that we actually render. Because it's quite tedious and potentially not very expensive, but a bit expensive. Yeah, maybe I don't want to add this. After all, so yeah, this is then the correct way of moving it, although let's see, direction is able to be let's see if we do let's see our offset here. GXE call print. Direction currently delta X delta C -1, yeah. So it kind of like seems to be getting it. Okay. Yeah, we're moving. Yeah, so it actually works. Uh, plus equals delta X times 0.5 delta C times 0.5. Okay. That seems about right. I mean, the end positions are totally fine. So yeah, so the start position is here, then the end position is here, then well, yeah, so that's the starting point for each part of the conveyor belt. So, and this is supposed to center it, and then we end up, okay. So it does look more like a path you'd expect, right? Huh. Yeah, okay. These are the offsets. Mm, okay. Let's just keep this out of the equation for now. So the object is traveling along the right path. Yeah. Maybe we do want. So you're supposed to travel like this. This is the direction. This is the direction. This is the basically. Okay, let's simply start out by calculating the current grid position. It's way simpler because we're trying to do stuff in absolute terms here. So int item start pause apps. This item start pause apps. This is of course X. This is C. Then we will have item pause apps equals 0 right now. Okay. Let's reason about this. So we will have an okay, so this is our absolute coordinates. Next index is this. Let's do an int direction x equals int direction set. The same thing here. Okay. So this gives us not only our absolute position, but also our direction. Okay. Let's do an interpolation value here. And right now we won't move anything because it will just stay. And then let's just print these values here. Current calculations. Interpolation. Let's start out by doing that. Whoops. This usually crashes it, so let me just reboot. Yeah. It's up there. Okay. And for now, we will do like this, so that we don't get weirded out. So let's see, we're done. Yeah, so we start out by our interpolation value here is okay. Let's do our interpolation value here is whatever remainder we have of our exit gap. But we're subtracting. Oh, it's because we're flipping it. That's why. Okay. So let's see. Yeah, we do end up with a negative value. That's not great. So 1, okay. 1, then we go down to this, and then we start over at 1. Okay. And then we do okay. So our interpolation oscillates between 0 and 1. Let's see, maybe we don't even, oh, we do want the direction. Okay. So our item position X is equal to our item start position plus our equal to our start position plus our item position absolute X. And let's do this. So this should make our object move again along the path. Right now, doesn't. Oh, that's in absolute terms, of course. That's not. Well, let's just do this. Yeah. And this is supposed to be some interpolated values. Right now we will do like this. So whenever our value is high, we're at the start of the segment, which means that we should let's do interpolation times minus 0.5 times direction x. And let's do it all in float here. Okay. And let's do the same thing. Let's see. No, it's not really teleporting. Um, if you watch the video on my channel, I actually don't have problems teleporting. I have problems in transferring the item position from relative space on the belt segment into absolute coordinates and blend between the different stuff here. So yeah, I hope that explains it somewhat, but I'm not sure. Okay, let's copy this term, except let we do 1 minus the interpolation here and swap the sign. Okay, let's try doing that. And let's do C here and C here. Okay, and let's flip these signs here. as well. Okay. Yeah, so it's almost correct. The only problem is whenever whenever we hit a corner case. Uh, yeah. So if we just had like segments that were going in the same direction, for instance, if we didn't do this, but just did this, and then added a fourth one here, I think we should be doing everything. Oh, at the end, it's like, yeah, it's definitely an endeavor. You need to learn a lot of different stuff. Yeah, for some reason, okay, maybe the interpolation value reaches a wrong factor. Let's see. Let's do this, although I don't think it will look. Okay, then yeah, it was related to the actual end value. Maybe just add a value here. No, it's still teleporting on the boundaries. Still teleporting on the boundaries. I'm working on curves in the belt system. And how are you? Yeah. So I got a normal piece of belt working, but whenever we do turn some, then I need to like calculate the absolute stuff. Absolute stuff, I just say, because um, it's tricky translating from relative position into um, absolute position. I'm pretty good. I'm pretty good. So it knows the actual item position from the uh, entry gap. Uh, so it's able to actually interpret that it needs to go around a corner here. Uh, Also, if we tried adding something else, let's do maybe add another build piece here at 2, and then 3, and then we end up at 4. Yeah, so let's see. It knows how to track the item. Yeah, but splitters are that stuff in conveyor belts are somewhat Yeah, it's not that tricky, but it's something different. Right now, I'm just trying to handle this transport lane stuff. Sure thing, buddy. So, offsetting by using the exit gap is obviously working. At least in terms of relative position, or rather absolute position in the game world. Okay. So if we're interpolating too much, let's see. All right, let's add this back. And see how close we got. Yeah, so on the corners and on the boundaries, we have some problems. Yeah. Does the exit gap need to update even more, actually? Let's see. And what happens if we do this? -0. That's fine. Let's see. We should be in a state here if direction X unlike 0 and direction C unlike 0. exe call print corner else not. Let's see, did we actually print out corner? No, because it can't really deduce that we are in a corner. Uh, since it's using absolute coordinates. Oh, I guess that's the downside of actually doing it that way. Alright, be right back. Bathroom break. Alright, I think that if we revert back to the old system with the uh what do you call it? Let's see, directions. Let's disable this. But let's just do type here. And then do like this. And let's enable all of our old code again. So let's disable this. Good thing we saved it. And we store the end position. And right now, of course, we need to change this as well, I think. Yeah. Won't need this. Also, let's add this back. Also, up here, I think we revert back to this because the type will allow us to do basically exactly the same thing, except that we can look up or treat different cases differently. Yeah. So let's see, where do we have errors? Construction. Okay, so we're basically trying to do something wrong somewhere. Oh, there. This is the old way, or rather new way. So let's add these conveyor belts. Okay, so we have this belt set up. Right now we don't actually compute the position of it. Okay, so let's do what we just did, but for um, our stuff. Okay, so the start position will calculate Yeah, right now we will use this. And let's see, we had a type right. Tile offsets. Okay. And let's do so for each item, we'll set this to our absolute position here. Let's do the same thing for the C. So right now this should spawn our box at yeah, this, but it won't update it. So so let's try to see if we can use the new system here to actually compute our absolute position. Absolute position plus equals let's see. Let's copy this. So for each tile before, we add the direction X factor, and of course we add the C factor as well. And we have our absolute position back. That's great. Okay. So that actually works. We accumulate the offsets here. And get our absolute position. And then we could actually add a different factor here for different cases. So let's try that. Let's create a set of interpolation values. For instance, let's do this. Let's just run it with the first four first types here. So it won't work whenever we move on. Okay. So we have our let's see. Let's calculate our type because we use it so many times. Const unsigned int. Also, let's const this. Type. Wait a minute. This is wrong. This is correct. Okay. Okay. So we have our type. We have our interpolation value here. So and let's do factor interpolation values, interp values. Okay. Let's copy some of this stuff here, although not use it directly. Let's see. So what do we want to interpolate with? Okay, right now we'll just be where we were before. But our current value here let's do interpolation plus interpolation times our interp values. Values dot x factor okay, let's start out by doing that. It will not look right, but maybe even minus. Okay. So whenever it looks so funny. So whenever it crosses the middle, of course, it doesn't work. So let's interpolate like we did before. So let's do interpolation here plus whatever we end up with here. Okay, and let's do plus then 1.0 minus interpolation times this. Okay. Okay. Yeah, so we end up in trouble with our corner piece, of course. So it's a piece with the type of 8. So let's change the value number 8 here. Maybe 7 or something. Was that right? Let's see. I think this needs to be negative for this one. Okay, so we're not that far off, I think. Also 3. Do we need to flip the sign on this? I don't know. No, we don't need to flip this sign on that one. Let's see. Hmm. Yeah, it's because it's like a curve, right? I can't really do it like this. Welcome back, buddy. Yeah. Try to make a Pokemon clone and not get sued by Nintendo. Oh man, that sucks. Mm, okay. Maybe it, yeah, it turned out alright then. Maybe we want to combine the two types where we actually, again, are able to set the endpoint. Well, I guess we are setting like, so from the absolute position, yeah, right now it just stay, but this should need some kind of smoothing function, or at least um, a I think a round edge is more logical because it will move one tile no matter what. So a corner should move things at the same speed. So do we need to predict? Maybe we need to track changes in direction. Mm, I mean, on a straight belt, we won't do anything. It's so easy to interpolate between different values on a straight belt. Let me look at my graph here again. Okay, so we could check for a direction change actually. We'll keep this just for now. So the same type will have the same direction. So when we jump to this, we will immediately see that we have a yeah. Let's try doing that. Uh, so if we add another one that is basically just a direction placeholder. I guess we could do that with the same thing, right? Okay, let's just start out by detecting a yeah, we won't do it. Let's just do unsigned int next index equals the minimum value of this and index plus one unsigned int. Okay, so that we don't overflow, and then let's see, next type, next index type, and then next direction. Float change x equals direction x factor minus a next direction x factor, and then c let's see, and then change x is equal to change x times change x, or rather float change vec mag equals this plus change change set times change set squared So if these stay the same, let's see, if above or equals 0, plus float epsilon here, I guess. Nah, that will make us surpass 0, I think. GXE call print. We surpassed. We had a change in direction at index. Okay, let's try that. And you too, buddy. Have fun. Okay. This is wrong, obviously. Let's see. With value. Now it's probably rounding errors somewhere. Yeah. We had a change direction at index 2, yeah, or rather 1. At between and next index. Yeah, so 0 is this one, 1 is this one, and then this changes the direction. So it actually kind of like picks up on the change of the Okay, so if we have a change in direction, we know that we are at a corner piece. Yeah. So at a corner piece, what do we want to do? What do we want to do? Else, let's do whatever we do here. Okay, let's see. Um, yeah, so this will only work correctly. Yeah, it looks quite funny. Ah, man. Should we just try to implement something that is somewhat curve-based? Yeah. Maybe I should draw it instead. Also, I need something to eat. I'll be right back. Okay, let's try reasoning about it on a drawing instead. Okay, so I have my belt. let's say that we have the actual belt here, and right now I'm just gonna do something that is not necessarily exact, and we will have we could have like an exit gap here, and then we could have an object, and then we could have whoops, an object here, and then we could have a gap, and then we could have another object, yeah, and then we would have the entry gap here. So this is our conveyor belt abstraction, and this is the world version of it. So we will draw some kind of belt segments here. It doesn't matter because this is relative position to this whole segment here. Let's just do something like this and then like this. So we can map this whole line here to the whole path. So let's just do something like this is the whole, maybe another color. And we want to actually do, let's see, we want to do something like this. Whoops. Yeah. From this total distance here, which will be it will be the red line total. So that means that we actually have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Oh, that's way too small. I guess we want to do something like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. So that's basically it. So this is basically a problem. We can easily move it in a straight line because it's basically so easy to map. If we store a belt piece type, which can look up whatever direction it has, it'll probably be easy to draw them because uh, so this object here should actually map onto the middle of the this one here, right? Curve a direction vector interpolation between two vectors. Let's see, can I get... Hmm. Curved corner vectors. Calculate. Let's see. Elliptic arc curve math. Oh yeah, we could, well. Of course, just use a function. Maybe we just want to calculate the Yeah, we want to calculate some points. Um, so we want to create a curve or what? Yeah, we can calculate whether we're turning. So if I from this to this, there's no direction change. From this to this, there's no actual direction change. So uh, we could then maybe we could create a list of points. Maybe we just want to create points. Maybe we just want to create points. Huh. Huh, guys. Now you're thinking with portals, right? Uh, mm, yeah, maybe we want to create some control points here. Control points around these spots here, because these vectors will be able to be interpolated between. Yeah. Also, so we won't be using this. Let's do directions again. So we will have directions for each of our tiles here. And let's move this up. Okay. Once again, I think I'll start over. Let's see. And this doesn't crash because we actually have these values hard-coded. Okay. Yeah. So we have our current index. Let's do a struct here. Point. Float x. Float y. And let's do a vector here. Point. Points. Points dot reserve 2 points here. Maybe we want, let's just store it for now. Let's remove this. Let's just do a build. Not only will we store the type, but we will store the index offsets, blah, blah, blah. So let's copy these. Nah, let's not use the type or what? No. Okay. And let's do like this and then comment this out and then subtract 2 again here. Oh my god. Offset. What's that? Oh, there we go. There we go, and let's -1, and then we do -1 here, and down here we will do, oh, we already do that. Okay. Okay. Yeah, so we have our stuff right here. 1, 2, 3, 4, 5, 6. And let's do look up that stuff. 1, 2, 3, yeah, 6. Okay. Well, I guess I want to actually yeah, the direction change over one tile. From this to this, it's only on the X. From this to this, it's only on the X, and then it's only on the Z, Z, Z. So this will not actually give us any way to reason about the actual direction of that sort of tile. So let's actually use the type value here as well. And then let's map onto this. So this is going to be a 0 piece, a 0 piece, and this is going to be a corner piece, right? So it's gonna change the direction where we simply increase the set value. So not only do we increase the set, we also increase the X because we're moving 1. So let's see, and then we're going down, we're increasing the set. So that means we will have a 1 type here. Right? I think so. Yeah, we have 2 there and we have 3 down there. Okay. Okay. So we both have our offsets relatively speaking. And we can use the type to actually select the model as well, which is pretty cool. Okay, so we can calculate 2 points here for our belt segments. Next index is equal to the index plus 1. Let's see. Let's see the type. Huh? Did I not? Yeah, I did edit. There we go, and let's do a duplicate version of this and do next index, next type. Okay. Let's see, point, start point equals, let's just do like this, start point x equals okay, the start point for this one equals the absolute position, right? Maybe we just want the belt piece. Belt piece. Belt piece. Next. Belt piece. The is this a float? No. Plus the item start position. Plus, no, minus 0.5 times, let's do a belt. Is it belt end directions? I think so, isn't it? Yeah. Next direction. Segment dot direction. Or not? Is it directions or is it tile offsets? No, it's directions. Let's see. Next belt piece dot type here. Okay, and let's do the same thing for the. Let's see, belt piece dot type. Okay. Okay. Times the direction dot x factor, and then let's do the same thing. Let's do set here. Let's just do gxe call print start pos. And let's see. Yeah, okay. I forgot to check it, of course. Okay. Let's see. So far, our first one, it seems correct. Then we move tile or what? Yeah. And then we swap the tile itself. So we actually still end up at the correct position, but then the start position gets off. Is set off because this is actually not correct. This is actually not correct. Because the start position for the corner piece is, or rather the start point is, of course, on the Z axis. Okay, let's try calculating the magnitude. Direction X and next direction. There we go. If the magnitude here squared is something, otherwise we will do like this. Okay. Yeah, so it should skip the corner piece, right? Okay. So yeah, 2.5, 0, no. Huh? And then we're at that doesn't make any sense, right? That doesn't make any sense. Because If we do something like no, I don't think it will work. No, it won't work. It doesn't make any sense to try. So what should we do here? We don't calculate the starting points correctly here. I mean, the last two. Yeah, and immediately, since for the next one there's a difference, it won't work. Yeah, so this is not the way to go right now. Hmm. Yeah, so we're really having trouble doing this, so maybe we just want to check the type. Yeah, maybe we just want to do the type if the build piece type is below 4, we will set it like this. So for straight ones, we should be calculating our, yeah. And then for the corner piece, we're not. Okay. So else we have a corner piece here. Straight piece. Corner piece. Okay. And of course the point endpoint will be the same thing except plus. Otherwise, we need to well, we basically need to access the direction, right? Yeah, we could always rearrange them. So if we rearrange these so that well, yeah, how should we actually rearrange them if so this is our points. And pause. The end pause is wrong though. Isn't it? I'm pretty sure it should be something else. Huh? Oh, it's because I'm not dumping it. I couldn't make any sense of it. There we go. Yeah. So we have one unit in between. Um, okay. For a corner piece, the start point and end point would be something like here and here, and this would have a vector, a direction, for instance, like this. It would be 1 and then -1. Yeah, so the x would need to be multiplied by the value, and then I don't know. Let's not set the endpoint right now. Ah, whoops. Oh, did I even end up far enough down the belt? There we go. Okay, so our start position is still the same, and for this particular type here, 4.5 and 7.5. At least that's the same thing as the previous endpoint, so that's correct. At least for this one. So we have a 4. So that means, yeah, negative there. But it has a, yeah, the offset is not interesting, but the C should increase afterwards. So it's actually not this one. It should be this one, right? Am I 4? 1, 2, 3, 4. So that's 3, that's 4. 1, 1. Yeah. Right? 1, 1. Yeah. Because it ends up increasing that. Okay. At least make it work for this case. Ah, whoops. So for the corner case, uh, okay. So it does seem like, oh no, that's the endpoint, right? Yeah. Oh. Oh. So how do we decide whether to add on the X or not? So we should maybe, Yeah, so that's a problem. Because when we want to start on the okay, maybe we simply want a major switch here, although it's pretty nasty. Okay, maybe we want to uh, calculate a delta factor here. Well, let's see, delta x. Delta set. Let's see. Delta. Oh, whoops. Okay. I'm not sure this will work if we kind of like stack corners. We could do another nested if. But let's try it. Let's only do it. No. So we add type 4 here. And we can see our, where's our transition? Here. So our start position. Shouldn't be like that. Oh, it should, I think. Okay. So our start position is correct, at least for this type. One minus delta x here. 1 minus delta z. Let's see. I don't know. It probably won't work. At least not as a generalizable case. And let's see. Well, not the... Yeah, okay. Let's see, maybe this is correct. So it actually ends up moving from 4.5.7 down to 5 on the X, and then this is actually correct. Okay. Let's remove all of this. But let's create a series where we instead of let's do -1, -2, -3, -4, and then we of course need to add number 3 here, and it takes the still the positive x component, but then it flips it. So this would be a 7, right? Okay. Let's try it. It probably won't work. Okay. So let's see. We move on the X. That's fine. No. Oh, yeah. So from 2.5 to 3.5. 3.5 to 4.5. This is the same. Only the thing here needs to be subtracted. Yeah, so the other component is actually wrong. Yeah, so it doesn't handle the maybe the sign on the direction is supposed to go into this. Okay. So yeah, it works fine for all of these straight cases, but huh. This is also wrong. Oops. This is obviously maybe just subtract here. Whoops. Usually this is the subtraction and this is the addition, right? Yeah, you up here it is. So let's see. Okay, so the start position is that, and then, oh, that's actually correct. That's actually correct. That's actually correct. Okay. Let's see if the test case is then correct once again. For yeah, the start position for this one. Yeah, it works at least in this case. I don't dare testing it. Okay. let's see. Maybe we don't need to do this. Let's see. Can I comment out this? Or will I run into trouble? Oh, I've been coding away. Point interpolated. Point. Dot x dot y. That's it. Okay, and then interpolated point equals start at the beginning. We want more of the start point dot x interpolation dot x plus, or is it minus? No, it's plus 1 minus interpolation times endpoint dot x. Great. Hello, buddy. How are you doing? Okay, and then the last thing is actually an interpolation error. I'm pretty good. I'm pretty good. Oh, we got ourselves a new subscriber. Welcome, Jaro. Thank you. So far, we're interpolating their path, so that seems pretty cool. Let's see. Right now, the only error is like the end point here, where the value gets too big. It's taken me all day to get to this point. But now I at least think I do have some of it working, almost at least. Now all that is left is more testing and bug fixes. Should we do a celebration of your viewership, Mr. Yes? It was hard to map from. I had to do an algorithm that maps from how the conveyor belt is laid out in memory. So our conveyor belts do not store the object positions in absolute space, but only in relative position space. So that means that we actually have these lines here that what do you call it, affect the object placement on the whole of the belt segment. So you have to kind of like translate that into absolute coordinates in terms of actually rendering something to the screen, because a object needs absolute coordinates, if that makes any sense. It just took forever to do that interpolation, and we're of course not finished yet. It only works for one object right now on the belt, and it's not 100% done. Anyway, so, oh, this is not. Anyway, let's see. I wanted to do a celebration since you're here. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Are you ready? Oh, we need a better texture. Here we go. Yeah, that's really nice. Yeah, buddy, we got Paul back. Okay, but I'm gonna mess with the last piece of the puzzle. Yeah, maybe you'd find him in a mining shaft somewhere. Indeed, indeed, he could. Okay, we don't end up using this one, so so let's see. What's the index then? 0, 1, 2, 3, 4, 5. Mozart? Who's that? I mean, not the real Mozart, I suspect. um, and chirp. I don't know that guy. Maybe let me look it up. Aren't we actually? Or maybe we need to be equal to. Let me Amadeus Mozart. What's the song name? Now you got me here in Mozart. Yeah, so it jumps up immediately. So the way I okay, let's this will bug it out, but oh, let's see. I'm not sure that's correct German, is it? Oh, the track is it's ganz kleine Nachtmusik. Okay. So here, okay. I've just found a podcast about it instead of the actual track. I guess it's not on Spotify yet, if it recently got discovered. Yeah, so exit gap. Yeah, he was faster. That would be crazy, huh? At this speed, I'm not sure I'll be able to. I think we'll see GTA first. Let's see. Let's try doing this from index 3 and down. Due to the rounding error, we end up in that situation. whenever we enter index, yeah, so that is probably part of the problem. So this way we end up with a correct exit gap value. Float hole corrected. Oh, that's nice. Always exciting to add new stuff, get new problems to solve. Oh, of course I didn't print it. Hole corrected. Let's see. So we're still. Yeah, so the hole corrected is, of course, yeah, so the problem is only when we overflow. Let's do interpolation equals the std max float here of interpolation itself and then 0. If we clamp it, and let's disable this stuff here. Yeah. What's your current problems? Oh my god. It kind of like jumps back. Why does it jump? Let's see. Yeah. Oh, maybe we just want to clamp it. It shouldn't be above 1. But it will jump back to 1. Uh, oh, that's a big problem, man. corrected exit gap. Exit gap. Corrected exit gap here. It's so low. Yeah, maybe we want to actually, instead of doing this, maybe we just want to add it up here, because we're kind of like ending up in a state where we have a negative number. And then the corrected exit gap here. There we go. So now it's correct. Okay. Let's try adding another item. So let's do float total gap equals, and let's do maybe a corrected exit gap up here. And then let's just do this, and then total gap here. And thank you. Also, feel like it's getting places, so this should not change anything, right? Yeah, so we're still good. Okay, so in order to actually add items, right now we would be able to add items, but for instance, let's just do a quick, this is not needed. I just realized, okay. And this shouldn't be either, right? No. Okay, we're cleaning up this stuff. Okay, and then let's just print as a proof of concept if we have more than one item. Because I'm pretty sure we're actually spawning objects. Yeah, buddy. Can't spell, but it doesn't matter when you're shouting. Doesn't need to sound like words. Yeah, so we actually do end up creating the item. And then yeah. Oh, you had to change to 2 times float or whatever for your vertices, or 3 times, or okay. So for this item here, let's try adding the item gaps. So for int gap equals 0, gap less than segment dot gap index. Let's see. Equals item, perhaps. Okay, let's figure out how this is laid out. So when we create our item, we create a gap, and that's for our first one. So that would mean no, that's I don't know either. So for the first item, we don't want to do anything, but for the next item, so item 0, no additional gaps. Item 1, first gap. Item 2, first and second gap. So when we fill out the gap vector, we also increment the index. So let's just do how do we end up in that state? Let's think. Um, so if we do like this for int gap, yeah, exactly. Oh, let's see. I'm not sure I understand. I don't know your data layout, but yeah, I know the problem with the calculating sizes at least. Sometimes it just ends up not working. Okay, so in here we actually decrement the Hello, how you doing? I'm just working on this conveyor belt stuff, actually fixing, doing multiple items. So when I click this, we should add another item, but right now it's just on top of the... Yeah, I am. It takes a lot of work to make it all work, especially when the conveyor belt is abstracted in a very efficient but somewhat complicated way. We're not storing the absolute positions of the objects, we're just storing them on a set of lines. So if the conveyor belt itself takes a turn, for instance, yeah. Okay, so let's just write out the case here. If item equals 0, do nothing. If item larger than 0, add the first gap. Add the following gaps for each item. Count. He works on a different game. I think he works on a puzzle game. This is not going to be a puzzle game. I'm not really stuck, I'm just thinking. It's been steady progress all morning, so, and I'm actually at a state where this works like it should. It also works in the other direction, so I just need to add the total gap calculation to the problem solver here, and then it's done. I'm neither. I'm just a hobby programmer. I work at a hospital, so I have no education or no job within the field of programming. Thank you, buddy, and always nice to have you here. Good luck with your work. So there will be a difference. It's just a hobby, so I just wanted to do programming, so that's why I got into it. I found it fun and interesting. How about you? Oh, cool. Yeah, that's also pretty, really interesting, rather. So I definitely follow your interest. Let's do const here. Not that it matters. No, no, I'm not. I work at a hospital. I have a very good job. Okay, I'm getting close to. Oh, I'm so happy to hear, man. I'm glad you found it helpful. It's really nice to know how the computer actually works, right? Oh, cool. Yeah, that's just the way the world works. Education only can take you so far, but at least it teaches you a way of thinking. I'm not using much from university either, but some of it I do. And at least it's a foundation, so. But if you're persistent and know which resources to use, you could do most stuff without an education, except for like what I do for work. You need an actual degree to do that. So some job titles are definitely protected by degrees. But if you want to do IT or programming, it's definitely not wasted, dude. It teaches you a way of thinking. And no one's stopping you from doing stuff on the side where you learn even more or even build projects. So basically, if we do an unsigned int here, it will overflow, I think. So unsigned int gap equals item minus 1. And then if the gap is less than, well, not at hospitals, dude. You won't get work at a hospital without a degree. And good thing the same, I think. I think some professions are supposed to be open for non-degree holders and others aren't. Let's see. Let's just print this because I'm unsure how it will work. Stuff. And gap value. Yeah, exactly. Got it. Yeah, so it only runs stuff item 1 gap. Cool. Let's try spamming this button then. Yeah. So we can't really yeah, that's good. So it will only activate whenever we're past the first item. Yeah, so that actually works. Let's do mindful of unsigned int overflow. Okay. Total gap. Uh, okay, this should as a hobby for 2 years or something like that. But if you were to calculate it in full time, I don't know, it would probably be less than a year, maybe less than half a year. I'm not sure this is. Yeah, so if we're at item 1, we will start at. Yeah, okay. We don't want this. Let's see. Yeah, I did web dev when I was a teenager, but yeah, in my opinion, web dev is not that interesting anymore. At least to me, doesn't even feel like real programming to me these days. Okay. Mm. Let's do it again. Let's map this out. So item 0, nothing. Item 1, gap 0. Exit gap plus exit gap. Item 2, gap 0 plus gap 1 plus exit gap. I've had small breaks. I guess you could iterate the array from the other side, so uh, so if we have the entry gap plus, or rather minus, no, well, the exit gap minus the entry gap would give us, um, so it would, if we're trying to, so the first one here is just the exit gap. Then we have gap 1. And yeah, the total offset would be the exit gap plus the gap itself, but we could also do it the other way around, I think. So if we do like this and then change this into another gap. So let's say that it's like this instead. Then we would have for item this, we would have the entry gap. All right, thank you, and thanks for tuning in. Hopefully I'll see you around. Take care, buddy. So the entry gap is the last item. And then so when we're processing this, we will just do the exit gap, or we could just do the entry gap as well. I actually haven't thought about using the entry gap itself. I actually think that it would probably have been easier to do it the other way around, because then you're like probably iterating the wrong other way. Anyway, it probably wouldn't matter too much. Maybe item. So for the first one, we won't do anything. Is this just the way we want to go? Yeah, I think so. Total gap plus equals segment dot gaps gap. Let's try that. It's glitching, but oh, and let's do this, of course. Whoops. There we go. Okay. So it should probably be the same thing as controlling the character. Not this one, it's inside the draw call. Let's see. Rotation. And let's copy this stuff here. Let's do the hello, buddy. Yeah, I'm almost done for today. Uh, let's see. Let's see. Direction dot x factor 0 direction c factor here. Okay, let's compute a quaternion and let's set the belt transform here, orientation to our rotation. Okay, it's definitely not rotated correctly. Uh, can I flip it some way? No. Let's do minus here. No. They aren't rotated correctly. Oh man. Now they look totally messed up, but at least our stuff here will look correct. It looks like a series of planks instead. uh, let's try. Oh, this shouldn't do anything, right? No. Yeah, I need to fix the model itself. This won't work. Maybe we want to store a set of rotations. Anyway. Okay. Yeah, it would be better if it was more curved, right? But right now, it is what it is. Let's see. Okay, and then we just need to call the non-visible belts because we don't need to draw them, the items on non-visible belts, and they'll be updated accordingly. Yeah, I wish I could have I guess you could make this more efficient by actually creating some kind of buffer where you store the points along the belt segment, and then you calculate all of the corner pieces, and then you calculate the straight ones, and then you simply just iterate over them instead. So yeah. Let's see, whenever I create the model, let's do 0.5 here. At least this looks more realistic. Well, not realistic, but proper. No, we can't do that because they won't meet. Okay. I'm gonna do a few more tests here. So far, yeah, I'm not sure it actually will work in all edge cases. Um, let's try creating another belt series. Also, this one needs to go since it's not really used. Oh, I know I'm just gonna work on it. If I find a bug more, or rather find new edge cases, so it's probably not done yet, this system. Um, but at least we have corner handling to some degree, and we have several objects. No, this actually got spawned within too small gap. Funny. Okay. Anyway, since I started working this morning, before I actually got to streaming, I think I'll end the stream here. I gotta go do some other stuff. But thanks to everyone who tuned in and subscribed during the stream here today. It's always nice to see more people joining the channel. Um, but thanks to everyone who tuned in. Hopefully I'll be seeing you guys around. If you found it helpful, entertaining, inspirational, or something of the like, please consider supporting the channel by subscribing, commenting, or uh, some of the other ways that are listed in the description down below. Alright, please keep on trucking and take care. Bye bye.